Good afternoon, everyone. My name is Jingbo Liu. I'm a data scientist with background in oil and gas industry. My capstone project is about image recognition at pixel level by artificial intelligence. My presentation has three parts: the motivations, the methodologies, results, and demo. This is a fully interpreted seismic images, typically in oil and gas industry. Our geologists look at these pictures and make the detailed labels on these pictures. So this interpretation is important because people make decisions on where to find the oil based on this. And also it's time consuming because it has to achieve the pixel level accuracy. Let's take a look at the raw seismic image and try to do the interpretation yourself. Then do it again and again. People feel tired and start making mistakes. These are very costly mistakes. The motivation here is artificial intelligence and deep learning is growing like crazy these days. So are we there to use the state-of-art algorithm for these pixel level image interpretations? For seismic interpretations, it's very similar to semantic segmentations that is in the computer vision communities. Both of them need to achieve the pixel level object detection. So the methodology. First, to achieve a successful deep learning project, we need the datasets. The datasets I used it from the MIT computer vision group. It has 20,000 labeled images that spread out in 150 categories and 1055 different scenes. With the datasets, we need a platform to train this neural network. I use Amazon EC2 GPU graphic instance. I use 3 different frameworks: the TensorFlow, Keras, and PyTorch. And the focus of this project is algorithm part. We need to find out the best algorithm to achieve this pixel level object detection. This is the network structure I used for this project. I did a lot of literature study, and it turns out this is a very forefront active research with a lot of big names behind it: MIT, Facebook AI Research, Google Research, and Berkeley Computer Vision Lab, Deep Lab, a lot of big names. So the discussion of the details is beyond the scope of this presentation. If you want more details, please go to my repo. In the end of the day, what you need is the input raw image and the interpreted images. Let me give you one sentence summary of what the trade-off or the details. Basically, we need the details to achieve the pixel level accuracy, but we also need the big picture to make the right decision. The result. So for my capstone models, MIT provides us baseline models. My capstone model beats that model slightly, 1% in the pixel level accuracy and 4% in the mean IOU. IOU means intersection over the unit. And these two graphs shows the histogram of the performance. So the capstone model is slightly better than MIT model. Beyond those numbers, let's take a look at the images, how it looks like. So in this image, the top panel shows the MIT model, the bottom panel shows the capstone model. The left is a raw image, the central part is a human label, and the right-hand part is a model predictions. We can see the capstone project is better than MIT model because MIT model predict the purple ones as a house instead of building. But for a human being, what's the difference of building and the house? It's very hard to tell the difference. But if you have a good artificial intelligence model, you can tell this subtle difference with a good accuracy. This is another example. I want to point out is the bottom left. That's our model predictions. If you look at the human label, the mountains are labeled in this picture, but there is a vacant part that is the rivers. The human didn't label these rivers out, but our artificial intelligence models, it learns from the other experience and label these missing stuff and rivers, and also identify some pathways and buildings along these rivers. Even though these two accuracy are slightly, so even though the artificial intelligence, the accuracy increased slightly, like 2 points increase, but the details is more important. Thanks a lot for your attention. So I want special thanks for the MIT Computer Vision Group for providing the data sets and the baseline model. Also, I want to thank for the open source communities to share the codes and make the research a lot more easier. If you need to know more information, you can contact me through LinkedIn. Also, if you need more details, you can go to my GitHub. I have a very detailed repo for you.